Driving forces behind a chemical reaction has to deal with what are some things that you might observe or be able to predict based on whether a chemical reaction is happening or not. For example, when you pour two things together and you see a precipitate form, that's a good indicator that a chemical reaction has happened. A lot of times when you feel the container getting colder or hot, or you see some light being formed, sometimes even just a color change. All of these are just different forms of what we call these driving forces behind a chemical reaction. Okay, so you see a precipitate form, you see some heat or some light, you see a color change happen. If some gas is made, or if you can have a voltmeter and you see an electrical current traveling, you also know that are also things that we call driving forces behind chemical reactions. Okay, and make sure that you know the difference between, remember what a physical change is when you're only changing states from solid, liquid to gas, and a chemical change. Okay, in the case of covalently bonded molecules, remember if there's only an interruption in the intermolecular forces, that's a physical change. Okay, that means you're breaking or forming new intermolecular attractions, but it's still the same chemical compound. Okay, but when you break bonds and form new bonds, then that's a chemical change. So when we talk about a chemical change, some possibilities, again, some of the things we already mentioned, you might see a precipitate form. And again, a precipitate is any type of insoluble ionic compound that you know the solubility rules now. So when you pour two things together, you very likely may get an insoluble ionic compound. That's, again, bonds breaking and new bonds forming. Okay, if a solution feels cold or hot during a reaction, then energy is being absorbed or released. We'll talk about that more in our next video. And obviously, if you see a light or a color change, that's also a possibility. Okay, in the formation of when you see the formation of a gas, you see some bubbles forming. Okay, sometimes it's really easy to see, but obviously there are some times when you may not see the actual gas being produced, but usually you can because you'll see some bubbles form. Okay, some typical reactions that you're likely to see on the AP test may be any type of metal, just a pure straight metal, zinc, iron, copper, whatever, and you place it into an acid. Now you'll notice here this is just a single replacement reaction where the zinc is going to kick out the hydrogen, and look what you produce is you produce some hydrogen gas, and then you produce zinc sulfate. Okay, now how might you know that hydrogen is being produced is you put a flaming splint in there. So you get a piece of wood and you light it on fire. Okay, and then you put it into there, and you may have done this in lab, and it will make kind of a popping sound. Okay, and what that is while this reaction is happening, you can capture that hydrogen gas, and then when you put a flame in there, the hydrogen will react with the oxygen in the air and make water. And when that does that, it releases a lot of energy, and that's where you hear that squeaking, maybe kind of a pop kind of a noise. It kind of makes you jump a little bit when you do that. Okay, and that's because the hydrogen gas is reacting with the oxygen. So, okay, another type of reaction that, again, pretty common on the AP test is you put an acid, in this case, HCl, and you put it with any type of metal carbonate. Now notice here, this is a double replacement reaction where the calcium is going to go with the chlorine to make calcium chloride, and the H goes with the CO3, and again, it should make H2CO3, but anytime you form H2CO3, that acid will break down into H2O and CO2. Don't ever form H2CO3 on the AP test. Always break it apart into H2O and CO2. Okay, now notice that in this case, again, you're using a splint that is glowing, so it's been lit and you blew it out and now it's just glowing, or it can be lit. If you put it into there, again, you've got a test tube with with carbon dioxide gas in there. You put it in there, and rather than there being oxygen there, it's CO2, and what happens is the splint will go out. Okay, carbon dioxide is not flammable like nitrogen gas, and so if you put it into something that is mostly carbon dioxide, or nitrogen or anything that's not oxygen, then that the flame will go out or the glowing will stop completely. Okay? There's just not enough oxygen to keep that flame going because you've got so much more of another gas in there. Okay, and then the last one here talks about the decomposition of hydrogen peroxide. This one's really, really common on the AP test. You're very likely to see that equation. When hydrogen peroxide decomposes, it breaks down into water and oxygen gas. Okay, and there's a couple things about that. Number one, when you buy hydrogen peroxide in the store, it's always stored in brown bottles instead of clear bottles. Usually like rubbing alcohol, you can buy in a clear bottle, but hydrogen peroxide's always in a brown bottle because they don't want more light hitting the molecules and breaking that hydrogen peroxide down even more. Okay, and so with the brown bottle, the light can't get into the bottle as easily, and so the H2O2 doesn't break down. Okay, this happens just all by itself. Hydrogen peroxide breaks down all the time. Okay, it's slow, but it will absolutely break down. Okay, the other problem is the oxygen gas that's produced, and so usually the lids on H2O2, you'll notice they're kind of loose, and what that does is it allows the gas to escape, because if not, the pressure would slowly build up inside those bottles that the bottles could explode. Okay, now what happens if, again, you're producing some oxygen gas, and this is actually if you've ever looked at, like on YouTube, the elephant toothpaste demonstration. The elephant toothpaste demonstration is basically hydrogen peroxide and a bunch of dish soap, and they make it so it goes really, really fast, and it produces a ton of oxygen gas, and it releases, and it makes all these bubbles. There's some really, really cool demonstrations on YouTube if you want to look up about elephant toothpaste. Now, what happens if you do this and then you put, again, a glowing splint into the test tube, is because there's such a high concentration of oxygen in there, that glowing splint will reignite due to that high percentage of oxygen gas. Remember, normal air is only about 21% O2. So if you have a test tube that's filled with 90% or higher O2, well then of course that oxygen allows that glowing splint to actually reignite and be back on fire again because of that change, because of that high concentration of oxygen in there. Okay, and so that's kind of just a brief introduction to, again, a few different typical chemical reactions. And again, the important parts here are what happens to those different pieces of wood. They love to ask questions about what might you observe with a glowing or lighted splint of wood if you put it into the test tube based on what gas is in there. CO2, it's going to go out. H2, it's going to react real quickly. And if you produce oxygen, it's going to reignite those flames.